Okay, hello everyone. We are now at our last and final example for lesson 9.1. So this will be more interesting because we have here two nonlinear equations. Okay, our equation 1 is, if you're familiar with equations of circles, this is an equation of a circle right here with a radius of 13. And we also have a parabola right here for our second equation. So let's see how they intersect and if they how many points do they intersect. So we don't know yet as of now. Okay, so let's try to find out using our different methods. Okay, so we will start with the substitution method, right? Okay, so we use I'm going to use equation 2. Going to use equation 2, and let's see. So x squared minus y is equal to 7. So I'm going to express y in terms of x here. So negative y. Oh, on second thought, we have a much better idea, I think. Because as you can see here, we already have x squared, right? X squared and also x squared here. So why not use x squared instead of using y or x? So you can also use x squared, right? So let's use equation 2. So x squared minus y is equal to 7, right? So instead of finding x or y, I'm going to use x squared because I can substitute x squared directly to equation 1. So x squared is equal to 7 plus y, right? So we already have here our equation 3. So that is, I think, the most efficient. Okay, so if we substitute equation x squared to equation 1, substitute 3 to 1. Okay, so what will we get? So x squared is equal to 7 plus y. So let's just write this down. Equal to 13. So this x squared is equal to this. So what do we get? So we will get 7 plus y, right? Plus y squared is equal to 13. Okay, so let's rearrange this. So we will get y squared plus y plus 7 is equal to 13. So y squared, if we subtract 13 from both sides, plus y minus 13. So that will be negative 6, right? So negative 6. Oh, what did I write? So this is plus y, and then minus 6 is equal to 0. Okay, so let's try to factor this out and find the roots here. Okay, so y, so how are we going to factor this out? So we have y plus 3, right? And then y minus 2 is equal to 0. So using the zero product property, we get y, let's write that properly. So y plus 3 is equal to 0. So we will get y is equal to negative 3. And y minus 2 is equal to 0. So y is equal to 2. Okay, so we have two values of y here. Let's just write y1 and y2. Okay, so let's substitute it to our equation right here, to equation 3. Equation 3. So you can use equation 1 or 2. So I just chose equation 3. Okay, so for y1, let's use another color here. Let's use another color. Let's say it's green, okay? Oh, or let's just use this red, okay? For y1, okay? So x squared is equal to, what do we have here? 7 plus negative 3, okay? So x squared is equal to 7 plus negative, that will be 4, okay? So x is equal to positive and negative square root of 4. So x is equal to positive negative 2. Okay, so we have two values of x for y1. Okay, so 2x for with the same y value. Okay, so we will see how this will turn out. So for y2, you will get x squared is equal to 7 plus 2. Okay, so x squared is equal to 9. And then x is equal to positive negative square root of 9, which is 3. Okay, positive negative 3. So how many ordered pairs do we have here? Okay, so let's list them down. List them out. So we have x So we have 2x here. We have, let's see, we have positive 2, and negative 2. And then we have the same value, which is negative 3. And then for the second pair, we have here 3, positive 3, and negative 3 with the same y value of 2. Okay, so we have 4 ordered pairs here. So this must mean that they intersected 4 times. Okay, so this is very interesting. So ideally, we are going to check for, we are going to check and substitute all of these values into our original equations to see if they satisfy. Okay, so you can do it as an exercise. So it is a good exercise. You can do it as an exercise. So we can save time here. We are just going to proceed directly to the elimination method, and we can confirm this if we go to the graphical method. So if this really are the points of intersection, then that is already a form of checking, right? So if these are the points of intersection, then our answers are correct. Okay, so let's do the elimination method first before going to the graphical method. Okay, so for elimination, okay, let's see how we're going to do this. Okay, so let's copy this first. Control C, and then here. Oh, I'm sorry for that. So we copy that, and then you go here. Okay, so we have right here our given. Oh my, not working again. Okay, so here we go. So how are we going to do this? Okay, so for the elimination method, so it is very convenient here. We don't need to do anything. We just need to multiply -1. So either equation 1 or equation 2, because we already have x squared here that have the same coefficient, okay, which is 1. Okay, so let's multiply equation 1 by -1. So what will we get? Negative x squared minus y squared. Oh, let's write that properly. Okay, minus x squared is equal to minus y squared is equal to -13. And then let's just copy equation 2 equal to 7. Okay, so equation 2 is exactly the same as the given. Okay, so what do we get here if we add both of these? So we will get, this will cancel out, right? So then what do we get? So we will have negative y squared minus y is equal to 13 plus -13 plus 7, that would be -6. Okay, let's continue here. We're running out of space. So if we multiply this by -1, right? So that it will be positive. So we will get y squared plus y is equal to 6. And then y squared plus y minus 6 is equal to 0, right? So if we take a look at the, we go back, as you can see here, we got the same equation right here. So naturally, we will get also the same values for y, right? Same values for y, and we substitute, and we will get the same values for x again. Okay, so we've confirmed that we've already, based on this alone, we've confirmed that we will get the same values for the elimination method and the substitution. So that is also another checking. And if we go to the graphical method, so this is the ultimate check. Okay, let's go there. So as you can see, we indeed have 4 intersection points. So -3, 2, and 3, 2, -2, -3, and 2, -3. So let's check if they are indeed our points. So there you have it, ladies and gentlemen. So these are our solutions. Okay, so that's it for lesson 9.1. So I hope you learned something in this lesson, and thank you for watching, and see you in the next lessons.